Thank you so much. Now we come to one of the most important challenges in this field, the coating part. And I'm very happy to have the next talk from Alex from ACM and Acktar. Alex, how are you doing? You can unmute and just start.
Thank you for your introduction. I'm doing fine until
Looking
now.
Forward to your talk.
Until now, very interesting talks. I am trying to share my screen, and I hope you
very
can
nice.
see
Yes.
it properly. So thanks again. We are Acktar, and we are doing coatings, but the other coatings. We are doing very black, deep black coatings and coated foils to suppress stray light or to absorb laser power, or also to create high emissivity surfaces. So it has nothing to do with anti-reflection coatings or with filter coatings that our other colleagues from, for example, Hoya or Optics Balsers do. We are specialized in high absorbance coatings for photonic systems. So I am the CEO of ACM, and we are the German and European subsidiary of Acktar. And Acktar is an Israeli technology company. We serve every market using photonic technology because everyone that deals with light is always to deal with light that he doesn't want to have in the system. And the medical industry is one important market that we serve. Epic presentations, especially here in the online meetings, are always about questioning ourselves and also questioning our audience. So that's why I have structured my slides into 3 questions. Why should you use black coatings in endoscopy, and how can you use them? How can you utilize them? And the last slide, absolutely, for the epic questions: what can we do for you and what can you do for us? So why should you use ultra-black coatings for endoscopy? And I'm not only talking about the legacy technology, but also about new technologies. It's about improving image quality by suppressing or absorbing scattered light in the system. The smaller the elements get, the more problematic scattered light gets. You also want to increase the sensitivity and the contrast on the sensor side by reducing the noise of the background signal. And another point is you want to work with reliable and harmless materials, and our coating is absolutely inorganic. It's biocompatible and cytotoxicity tested and RoHS compliant. So here you are absolutely on the safe side. Another advantage is you can bring our coating into every stage of the product life cycle into working. So you can take a existing, sorry, I don't know where this comes from. You can you can take it into an existing system to enhance the performance, but you can also bring it into new developments and try to reduce the complexity or the number of components that are typically used to suppress stray light, like apertures and lens housings. I don't know. Do you see the screen something? I don't know where it comes from.
Yeah, don't worry about it.
Okay. Okay. Next question, important question, is how can you use it? How can you bring it to your products? How can you utilize our black coatings? And we have so the process is a vacuum deposition where we apply a composite of metal and metal oxides on the substrate. And we do this either as a direct coating, so we apply the coating, the ultra black coating, on discrete parts. We are not limited to size, speaking of endoscopic systems. So the tiniest part we've coated on are below 1 millimeter in diameter. And the second option is to use a coated film substrate, a very thin film substrate from metal, from aluminum, from stainless steel, but also from polymer. Apply the coating and bring it into shape. Our coatings are suitable for a very broad wavelength range. And we do come from near infrared and infrared applications. And we have heard during these talks that working in the infrared, in the near infrared, is getting more and more important. So our coatings do work also not only in the infrared, but also in the infrared, starting in the UV, absorbing light in the UV, in the visible and in the infrared wavelength range. So we are ready to go for nearly any optical application. And in addition, our coatings do not have any autofluorescent signal. So you can also use it for like Raman spectroscopy applications. We can coat on any vacuum compatible material, so on close to any medical grade materials. We typically, for the endoscopy market, we coat on stainless steel, opto-mechanics. We have seen the very nice lens design with 10 lenses by FISPA. There you've also seen a huge number of opto-mechanical parts, and these are the typical parts where we apply our coating on to suppress this stray light. Our coatings are very thin in comparison with other technologies, and they do have a very reliable thickness and are conformal to sharp edges. And apertures, field apertures for endoscopes are a very typical application where our coatings are used. Yeah, that's maybe just a short introduction about what we can do. And now let's go into the epic questions. What can we do for you and what can you do for us? So I try to explain what we are doing. So very black absorbing coatings to suppress stray light in also endoscopic systems. We are making high performance optical systems possible. We can do this as a service. So you supply opto-mechanic parts to us where we apply the coating, but we also do, especially for the medical industry, for endoscopy systems, we do complete manufacturing, including machining of units, laser cutting, CNC machining of components, and also the coating. And we also produce ultra black foil. So this is what we can do for you. And what can you do for us? So we are always looking into new application ideas. So not new applications for the photonic, but new applications for our coatings. Maybe applications that are not related to stray light suppression, but for example, related to other applications. For example, we had applications like high contrast calibrating targets that we have realized for customers, or even customers coming from the jewelry industry that need a perfectly black coated something. We are always looking to test and to qualify our coatings in demanding conditions. Here we are always looking for a collaboration and also R&D collaboration in projects. If you come from the coating technology side, always also looking for improving our coating performance, for example, the mechanical resistance. So here we go. I'm looking forward to the discussion.
Thank you so much for the very nice talk. This is the darkest black around, and these applications are very large, and large field of applications also for space industry and all kind of imaging. Very, very interesting. Let me see first if we have questions in the room. Thank you for making nice, epic questions. Made it easy, my job at the moment. Thank you so much. So if we don't
Peter has a question. Peter?
Okay, Peter, please.
Hi, I just want to ask, is there any guidelines as to what kind of parts that you can coat? And like, for example, if I want to coat an inside of a very small part, is that doable? And what is the limitations?
So coating inside of parts is our business, because the optical path is always inside of something. So coating inside a part is our business. It's a bit limited by the complexity of the shape inside of the part, and also of the relation between the diameter, the open diameter, and the depth of the part. But coating complex shapes inside, that's what we are doing.
Okay, so the second question, I have a follow-up question.
Of course.
When I want to do parts with you, you do it on a batch basis, and how much volume can you handle on the single batch?
It's depending on the size of your part, because it's
very small parts, maybe 1 by 2 mm.
Well, I don't know how many pieces fitting in the machine, but this is a very tiny part. A lot of parts fitting in the machine. So we start at quantity 1 for prototyping projects, and we handle a high quantity for serial production. So 10,000s of units, 100,000s of units. It's no problem for our technology. We are very flexible with that.
I think definitely he can solve your problem, because I know the problem of Peter. This is obviously a huge room for collaboration. Another question is coming from Ralph, all the way from beautiful Finland.
Yes. Yeah, when you were talking about ultra black coatings for foils, what are the manufacturing volumes of foils that you can realize? I'm thinking of many cases where in the printed hybrid electronics world, also for photonics integration on roll-to-roll processes, we would really, really like to have coatings of foils that we can put around components that are really ultra black and that are absorbing all the stray light. Have you worked with roll-to-roll applications before? Can we buy your rolls by the truckload, basically?
You're most welcome. So our film coating technology is a roll-to-roll process. So it's the same coating process like for the batch, for the direct coating, but it's a roll-to-roll machine. So we coat on running meters on the film substrate. We are kind of limited in the width of the foil, but we can coat on running meters. We have, for example, a standard material where we coat on a polyimide substrate, a Kapton film, 75 or 50 micrometers thick. We can deliver it maybe not a truckload tomorrow, but during the next weeks.
Okay. Yeah, I don't think truckloads will be needed. I think it's always very specific small parts that need to be coated. But you offer the coating as a service. You don't sell the inks or at all, right?
Unfortunately, there is no ink. So it's a vacuum deposition process. So
okay. All right.
We cannot deliver any spray or something. That's not our business. So it's a vacuum deposition process.
All right. Okay. Thanks a lot.
Excellent. More email.